So we have first definition of differential equation, that an equation involving differential or differential coefficients is called differential equation. We all know very familiar, we all are familiar with the equation. That means if we are writing 2x plus 3y is equal to 0, this is our equation. When two quantities are equating with each other, that is become equation. Now what is differential equation? That means if we have y is a function of x only, then differentiation of y with respect to this independent variable x is dy by dx. Similar way, second time differentiation with respect to x is d square y by dx square, and so on. So these are our differentials, or we can say that differential coefficient dy and dx. Okay, so the equation which involve this term dy by dx, d square y by dx square, d cube y by dx square, so on, are called differential equations. Okay, so now for example, these are the example which we have of differential equation, that which involve differentials or differential coefficients. You can see dy dx, d square y by dx square, dy by dx here, or del z by del x. When we have a function, when we have function with more than one independent variable, that means more than one independent variable, and at that moment we'll just differentiate this z with respect to x and y partially. So we have this partial derivative. The equation which involve partial derivative also is called differential equation. Okay, and based on this partial derivative and total derivative, we have two type of differential equation. And first is ordinary differential equation, and second is partial differential equation. Okay, so now first we will see what is ordinary differential equation. So ordinary differential equation are those which involves total derivative. That means ordinary derivative with respect to single independent variable. That means if we have y is a function of x only, then uh, if we differentiate y with respect to x, so we have dy by dx. Here you can see that x is only independent variable. That means we have single independent variable, and if we want to differentiate this y, so we have to differentiate with respect to x. So this kind of derivative is called total derivative or ordinary derivative, and the differential equation which involve this kind of derivative is called ordinary differential equation. Okay, for example, we have this. These three are the example of ODE, ordinary differential equation. Okay, in which we can find as this total derivative. That means ordinary derivative dy by dx, or d square y by dx square, or d cube y by dx cube. Now, what is partial differential equation? So, the equation which involves partial derivatives with respect to more than one independent variable. That means if we have one function z is equal to this f of x comma y. So here we have more than one independent variable. So if you want to differentiate this z, so we have two possibilities, that differentiate z with respect to x and differentiate z with respect to y. But here we have two independent variables, so we have to differentiate partially. So we will use del, this del sign here. So this kind of derivative are called partial derivative, and the equation which involve this kind of derivatives, partial derivatives, are called partial differential equation, PDE. So these are the example of PDE. Okay, so based on these two type of differential equation, in this chapter we are studying about the ordinary differential equation. Okay, ODE, this one. Okay, so now we will understand which kind of ODE we will study in this chapter. Okay, so first we will find the order and degree of the differential equation, then we will discuss. So what is the order? The order of differential equation is the order of highest derivative appearing in the differential equation. So if we have any differential equation, ODE is given or PDE is given, so in that differential equation, what is the order of that differential equation? So highest order derivative appearing in that equation is called the order of differential equation. That means, for example, we have this differential equation. Here, this is first order derivative dy by dx, and this is second order derivative, and this is the highest derivative in this equation. So, highest derivative is of second order. So that means the second order is the order of this entire differential equation. Okay. Similar way, what is the degree? So the degree of the differential equation is the highest power of highest derivative. Okay, highest power of highest derivative. When the derivatives are, this is the most important sentence, when the derivatives are free from radicals and fractions. That means differential equation is in polynomial form. Okay, in polynomial form of the derivatives. That means every derivatives are free from radicals and fractions. What is the meaning of this? We will understand with example. Okay. So for the degree, we have this example. So here you can find the highest derivative is the second. Okay, and the high power of this highest derivative is 3. So degree of this differential equation is 3 and order of this differential equation is 2. So order 2 and degree 3. So highest order and highest power of the highest order. Okay. Now based on this topic, order and degree of differential equation, we have this example. Find the order and degree of this. This kind of example will be asked in MCQ. Okay, if there is online examination. Okay, so you have to remember this method. So what is the order and degree of this differential equation? So here you can see that highest order derivative is this, and the order of highest derivative is 3. So order of this entire differential equation is 3, and the power of this highest derivative is 2. So degree of this differential equation is 2. So here we have this equation, and in this differential equation order of highest derivative is 3, and so this differential equation is in polynomial form. Okay, that means this differential equation is free from fraction and radicals. So that means we can find the degree, and the degree of highest derivative is 2. So we have order is 3 and degree is 2. Okay. Similar way we have the second example. So again, here we can see that highest derivative is second order. So order of this differential equation is 2. That is final. But now to find the degree, as we told that all these derivatives are free from fraction and radicals. So here power of this is in fraction form. So we have to reduce this in simple number form. So by taking a cube on both sides, okay. So whole raised to 3 and whole raised to 3. That means this 3 will cancel out. So we have this, and by simplifying this we have 4. So now all the derivatives are free from fractions. Okay. Now we can find the degree. Order we can find before also. So we have order is 2 and degree is highest power of this. So by expanding this, highest power of this second order is 4. So in this equation we have order is 2 because highest derivative, and power of this highest derivative is 4. So degree is 4. Okay. So whenever we have this kind of power, that means fraction power of any this derivative term, then we have to remove this. Okay. Similar way, I have to tell you about the radicals. That means if the differential equation is given by like this square y by dx square plus 3y is equal to log of dy by dx. So in this kind of example, we can find the order because highest derivative is 2. So order of this differential equation is 2. But what about the degree? So degree cannot be decided because this derivative term is with any function. Okay, so this is the radical. So to find the degree, we have to remove this. But if we remove this by taking on the anti-log on both sides, so this term also gets stuck. So therefore, degree of this differential equation is not possible. But order we can find. Okay, similar way, if we have sine of dy by dx, somehow we have this, then even also we cannot find the degree. Okay, but if we have this kind of only differential equation, so we can remove this by taking inverse trigonometry. So we have sine inverse 2. Now we have order of this differential equation is 1 because only highest derivative is 1. So order is 1 and degree is also 1 because the power of this highest derivative is 1. Okay, so order and degree we can find if we have this kind of equation. If we have this kind of equation, d square y by dx square plus 3y and anything else, so we cannot find the degree because if we take this sign on the right hand side, so this derivative sub with inverse trigonometric function. Okay, but we can find the order, and here highest derivative is this d square y by dx square, so order is 2, but degree is not possible whenever we have this kind of. Okay, but in this example we can find degree and order by removing these radicals. Okay, so this is the basic concept of what is the differential equation, type of differential equation, and order and degree of differential equation. Okay, now we have one, as I told, what is the solution of differential equation? How we can decide the solution of differential equation? So a solution, or we can say that integral of differential equation is the relation between the variables, which is free from derivatives, and which satisfy the differential equation. Okay, this is called the solution. Okay, now for example, to understand what is the solution of differential equation, if we have this y is equal to c1 e raised to x plus c2 e raised to minus x, and we have this differential equation d square y by dx square minus y is equal to 0. Now we have to show that this y is the solution of this differential equation. That means we have to differentiate this y with respect to x 2 times, and we will put the value of that derivative here and put the value of y here, and by simplifying this, if we get this right hand side answer, then we can say that this y is the solution of this differential equation. And here you can see that this y, the solution contains only the relation between two variable x and y, and this solution is free from derivatives. Okay, as I told in definition, that solution is what? This relation between variables, and this relation is free from derivatives. Okay, and which satisfy the differential equation. Let me check that this y satisfies this differential equation or not. So we have y differentiating this y with respect to x. So c1 constant, differentiation of e raised to x is e raised to x. Now plus as it is, but differentiation of this e raised to minus x is e raised to minus x into minus 1. So multiply this minus 1 with plus. So we have minus c2 e raised to minus x. Now again differentiating with respect to x. So differentiation of y dash is y double dash, and differentiation of this c1 is as it is c1 constant because this c1 is multiplied with e raised to x, and differentiation of e raised to x is e raised to x. Now c2 is constant, and differentiation of e raised to minus x is e raised to minus x into minus 1, so minus minus plus. Okay, now we have second order derivative, that means this, so we'll put in left hand side. So d square y by dx square is given by this, and y is given by this, so we will put this two value, and by expanding this we can cancel out this two term minus plus, and this plus minus minus, so we can cancel out this two term, and we have right hand side. That means this y satisfy given equation, and y is free from derivative, and which is a relation between two variable x and y. So we can say that y is a solution of given differential equation. Okay, now we have type of solution. Which are the types of solution and how many types of solution? So let's understand. First is general solution. So which kind of solution is called general solution? Solution of differential equation in which the number of arbitrary constant is equal to the order of differential equation is called general solution, or we can say that complete integral. Okay, so in previous example we have seen that we have y is equal to c1 e raised to x plus c2 e raised to minus x, which is the solution of d square y by dx square minus y is equal to 0. Here order of this differential equation is 2. As we know that the highest derivative is 2, so order of this differential equation is 2. And in this solution, here we can see that we have two arbitrary constant. Okay, so as the definition, number of arbitrary constant is equal to number of order of the differential equation, then this solution is called general solution. Okay, where we have C1 and C2 are our arbitrary constants. Okay, now, or you can say that complete integral. This general solution is also known as complete integral or complete primitive. Okay, now for example, this y is equal to a cos x plus b sin x involving two arbitrary constant a and b. A and b. Okay, is the general solution of second order differential equation y double dash plus y is equal to 0. You can check as method of previous example that you have to differentiate this y with respect to x one time and again differentiate with respect to x second time, and by putting these two value y double dash and y in this equation you will get the right hand side. Then we can say that this y is the general solution of this equation, because this equation is of order second and we have two arbitrary constant a and b. Okay, and this y is free from derivative, and which is a relation between x and y. Okay, and that arbitrary constant, we can take any alphabet for arbitrary constant, that a b c d a1 a2 b1 b2 b3 b4 c1 c2 c3, but don't use x y z variables, okay, which we use already. Now second, particular solution. What is the particular solution? So the solution obtained from general solution, that means if we have this is the general solution, this is our general solution, because in this equation contain two arbitrary constant, this is our general solution. So now in general solution, the solution which is obtained from general solution by giving a particular value to the arbitrary constant. That means this two arbitrary constant, if we give this two arbitrary constant particular value, that means 2 or minus 2 or 1 by 2, any particular value, then that solution becomes, that means if I am giving c1 is equal to 3, so we have 3 and c2 is given by 2, so 2 e raised to minus x, then this solution become particular solution which is obtained from the general solution. But in example we will not by just taking the any constant for c1 c2, we will find by using some condition. Okay, we'll learn that later on. Now for example, y is equal to mx plus c is the general solution of differential equation y double dash is equal to 0. Now as whereas that if we put the value of m and c, if 2 and 3, or if we put m is equal to 2 and c is equal to 0, we have these are the particular solution of this differential equation. Okay, so we have two type of solution, that means general solution and particular solution. General, that means which contain arbitrary constant, and particular solution, that means which contains the particular value of arbitrary constant. Okay, now what is linear and non-linear differential equation? So the definition of linear differential equation is a differential equation is called linear differential equation if the independent variable and every derivatives dependent variable and every derivatives in the equation occurs in first degree only. Okay, that means they should not multiply together. That is called linear differential equation. If they are multiplied together or they are not in first degree, then we can say that they are non-linear differential equation. To understand that, we have y is equal to f of x. So this is our dependent variable y, and every derivative. So derivative of this is dy by dx, d square y by dx square, and so on. So every derivatives and this dependent variable must be in first degree only, okay, and should not be multiplied together. Okay, so for example, we have this. You can see that this derivative, and this y dependent variable all have degree 1, 1, and 1, and either of these three are not multiplied together. Okay, that means this differential equation is a linear differential equation. But if we have this kind of, that means this is the derivative which is of first degree, this is the derivative of 1 degree, this is the y dependent variable 1 degree, this is the dependent variable 1 degree, that means total degree of this term becomes 1 plus 1 2. And as we told, compulsory of first degree. That means this differential equation is non-linear because of this dependent variable and its derivative multiplied together. Okay, so each term has a degree compulsory 1. Okay, so in this in this lecture we learn about the what is the definition, what is the differential equation. Secondly, we see the type of differential equation, ODE and PDE. Now, after finding the type, what is the order and degree of differential equation? And based on order and degree, we have simple examples of type of MCQ. Then we have solution of differential equation, that general solution and particular solution, and what is linear and non-linear differential equation. Okay, this is the basic concept that you have to learn, you have to remember before starting this chapter. Okay, or this chapter or based on this topic, that means ODE, ordinary differential equation, or partial differential equation. Before starting this two chapter, you have to remember this basic concept. Okay, so thank you for today's lecture, and we will meet very soon with second lecture based on this basic concept. Okay, and our chapter is, don't forget, first order ODE. That means we will learn